Hi, welcome to Measuring Metrics That Matter. I'm Rebecca, and this is Elijah.
Hello.
Who are we? I'm Rebecca. I've been at Red Hat for about 3 years. I started on the controller API team, and then I made the move to performance and scale recently, and I focus mostly on automation controller.
I'm Elijah. I've been at Red Hat for 5 years. I started in QE and then moved into the performance and scale department. We focus on exploratory testing, regression testing, performance analysis, and contributing fixes and enhancements to the products that we partner with.
So up here on the screen, you can see that we have a quick agenda. This will come back, but we're just going to move right into why monitor controller. So Elijah, why should we monitor controller?
Well, automation controller is a complex piece of software that fulfills several functions. So when you're wondering, is my automation controller healthy? Is it keeping up with the workload? Is it fit for the purpose for which I've deployed it? It can be a little bit difficult to assess that because you really have to ask yourself a number of questions. Our stick figures here are giving us some example questions you might have. So first and foremost, most people are running jobs with automation controller. They're scheduling Ansible work and they want it to happen in a timely manner. So they might ask, well, how long is it taking to schedule my jobs? I deployed all these execution nodes and I'm launching jobs. I want them to start and run on those execution nodes. Now, when those jobs are running, there are possible errors that their infrastructure can, cause. Like, for example, let's say all of a sudden the disk on one of your machines the execution nodes is corrupted and just any job that gets launched there fails. Or your Git server is not working and all your project updates are failing. And you want to be notified before your users come after you about it, right? So you could you would potentially want to act on an alert that tells you, hey, more than a certain amount of your jobs are failing in the past time period. Then once you got your jobs running and they're actually succeeding, no errors, you want to know, well, is one of the kind of value adds that controller brings as opposed to just running raw Ansible is that it takes all of that standard out from the Ansible playbooks and it does some post-processing and stores it in the database and allows you to do all sorts of great auditing and other kind of post-run analysis. So you want to know, is controller keeping up with doing that job output processing? Now, the question is like, how do we do that? Where do we get the information to monitor that stuff?
Well, let's talk about it. So we gave this talk previously at Ansible Fest 2022, and we asked people how many were already using Prometheus to monitor controller, and there actually weren't a ton. Next slide. We have a high-level chart here of how we suggest, and we have examples up on the AWX repository. We'll link to that later. But we have a high-level overview here. So we have automation controller, and we have an API metrics endpoint, and we have Prometheus pull that API metrics endpoint, and then we use Grafana to pull Prometheus. And you can do both of those at whatever interval, thank you, that you may like.
Yeah, so let's get in a little deeper. So like Rebecca said, controller provides a metrics endpoint, and it's at the path API v2 metrics. Now you just do a simple GET request to this endpoint, and you get back this special text format that Prometheus knows how to run. This is a pretty well documented and used format. I'm sure there might be other alternatives for how to parse it, but there's definitely Python libraries that know how to read it. So if you want to go with your own tooling. One gotcha is that at the moment you do have to be an authenticated user so most of our test jobs, I usually create a dedicated Prometheus user so that I can identify, well, these requests were coming from Prometheus. And you can give this user basically no permission to do anything else. All it can do is log in and read these metrics. Now, once you got that set up and so the user can make the web requests, you can use that user either with basic authentication or token to configure your Prometheus scrape configs. So in Prometheus, there's a file well documented how to set up these scrape jobs, right? And so here we have an example from our AWX development environment. So for us, the AWX1 port 8013 is where is a Docker container where AWX is running. And this is showing that every 5 seconds, Prometheus is going to reach out using the admin user and a password, and it's going to use HTTP. It's going to make the GET request to API v2 metrics, and it's going to get back that text format. You see that params format text. So now with that, Prometheus every 5 seconds is going to reach out, get that data, and start building time series data. Now, Prometheus has some ability to kind of explore these metrics, but doesn't really compare to the amount of features for building dashboards as you have in Grafana. So again, Grafana is set up to look at Prometheus and gather data from Prometheus. So they call so Prometheus calls its scraped jobs like jobs, and in Grafana it calls its data sources data sources. So here again, this is from our example that we're going to show you later in the AWX development environment. So the Prometheus is running in a container called Prometheus, serving on port 9090, and we're going to in this case it's unauthenticated because that's just how we have Prometheus configured. And it's every 5 seconds going to go out and get data from Prometheus. And later, we'll talk about how we can use this data source that we've named AWX Prometheus in this case to build dashboards and alerts. So we talked about how to set all this up, but what am I actually even looking for, Rebecca?
Great question. So we have a few metrics that we have pulled out as things that are important that we think you should monitor. We've broken those into 2 chunks. The first one is cluster metrics, as you can see on there. And the next one is subsystem metrics. I just accidentally muted myself, I think.
For how long?
No long.
Okay.
No muting.
Okay.
All right, so let's talk metrics and automation controller. So these 2 sections, cluster-wide and subsystem, are different. Cluster-wide metrics typically prefix with AWX underscore, and these are all from the database. If you are already kind of querying your database, you could pull this anyway. This is just a better way to get it. And then we have subsystems that push data to Redis. There are various tasks happening in the background in controller that do push data to Redis, and the subsystem metrics refer specifically to those. Those are broken up further into task manager and callback receiver are the ones that we monitor right now. They're prefixed as such, and we'll get a little bit more into those later. So let's just go ahead and go right into cluster metrics.
So cluster metrics, I generally think a lot about them helping build context for what's going on. We asked at our talk at Ansible Fest, how many people were managing multiple clusters, and there was a lot of hands that went up because a lot of people have kind of like their dev environment where maybe they're testing out a new version of controller, or they're testing out new content or different features, and then they have their prod where they're running their daily workloads. So also in our testing, we are often managing multiple clusters. So on our main dashboard that you can configure dashboards that have variables. So you can use the same dashboard to look at different clusters. But then as you switch between the clusters, it's good to have kind of a banner on top that tells you, oh yeah, which version of controller am I looking at? How many nodes are in this cluster? All of these things help build context for everything else you're going to have on your dashboard, because otherwise it can be a little confusing to be looking at the data for different clusters. And for example, this banner here was all built using information from AWX system info, AWX instance info, AWX instance CPU, and instance memory.
So now that you know kind of like overview what you're looking at, you're going to want to know what's happening on the specific cluster. So we have 2 listed here, AWX status total and AWX instance capacity. These are helpful when compared in relation. So the AWX status total is the current total of jobs in each status. This is really not useful on its own, but it is useful to be able to correlate with other activity in the system. And then AWX instance capacity consumed and remaining should always be moving in tandem. If they're not, that something's really wrong. So we don't ever have that happen. But a good thing to keep an eye on is remaining and consumed capacity. Let's say you have lots of pending jobs and you don't have a lot of remaining capacity. That's kind of a red flag.
Yeah, that might indicate maybe you want to consider either launching your jobs at different times to spread out the load, or provisioning more capacity so that you don't have your job sitting around and pending for so long.
So this graph here actually shows how our remaining capacity goes down as the number of pending running jobs, running in yellow, goes up.
Yeah, so this is an indication that we're launching jobs and we have less capacity available because now we're using it.
Yep. So a couple more metrics to talk about. These are narrowed down by the instance. Instance-specific jobs are really useful because you might want to know, like, are a particular type of job ending up on one instance. So AWX instance status total per status of jobs, and then the launch type total. So let's say maybe a lot of workflows are ending up on one job. This will help you figure out if that's happening. And you can actually see that in this graph that we've pulled up here. You can see that I believe it's receptor 2 workflow that is purple. Receptor 1 workflow that is purple. Almost all of the workflows are ending up there. Not necessarily anything wrong in this graph, but definitely something to keep in mind.
So now we've talked some about the cluster metrics that are available. We're going to start getting into the subsystems. And again, to help kind of clarify, why are we making the distinction between cluster metrics and subsystem metrics? And part of it is because the cluster metrics, if you said, are from the database, but the subsystem metrics are coming from other processes, giving us data from basically their runtime that is not written to disk anywhere. It's not in the database. So like each time the task manager runs, it's going to send information to Redis, and then the metrics are able to pull that information from Redis. But that information is not in the database. So say if you restarted the application, there's no getting it back. So speaking of this, you're going to talk about one of the subsystems?
Let's do it.
The job event processing metrics is the first one we're going to talk about, and that's from what subsystem?
All right, so we're going to go ahead and zoom in on this chart. We saw this chart earlier, but we're zooming in on a different part. So the transform job output and write database. Let's kind of expand this. All right, so Elijah just talked a little bit about this process, but to expand further, on the left-hand side, we have Ansible playbooks. The output comes out from each of those playbooks or jobs. That gets into the dispatcher, and the dispatcher then shoves it into Redis. People are probably most familiar with Redis as a cache. And then from there, it kind of hangs out in Redis until the callback receiver has capacity. The callback receiver then takes that, transforms that data, and shoves it into the database. And you can see in the process where the metrics are gathered. So kind of like a logical question here is, let's say that we have like a bazillion jobs and we're sending a ton of output from the playbooks to the dispatcher, and it's all getting shoved into Redis. Well, we can overwhelm Redis, and then the callback receiver can't keep up. And theoretically, we could lose that data because that Redis is actually in memory. So we want to be able to handle the bursty nature of Ansible playbooks, of jobs, because, you know, if you're running a lot of things at once, which a lot of users do, we want to be able to keep up with that. So we want to watch this, but we actually do want something like Redis that can queue stuff up until the callback receiver can actually handle that and shove it into the database. This also means that we're not kind of like willy-nilly opening database connections. It's a measured thing.
Yeah. So some of these metrics that Rebecca's going to talk about are ways we can make sure that we're striking the right balance as far as, because callback receiver can only keep up with so much work, but we want to allow, like she said, for these bursts in activity where we get a little bit behind, but we catch up.
Yeah.
So how do we make sure we're keeping up?
Well, this first one right here is what we colloquially call job events lag, and that's a good way to keep up with this relationship between Redis and the callback receiver. So this is new in 2.3, and this is kind of a rough metric for how far behind your callback receivers are. Like put very simply, like how many seconds between the time that it occurred in Ansible and then the time the user could see it because it was in the database. This next one, callback receiver events insert DB, is a counter of events that have been inserted by a node. This can be used to calculate a rate, which is, individual value is not very helpful. Rate over time can be very helpful. Callback receiver events queue size Redis. This is what I was talking about earlier. If this gets too high, Redis will fail. So this is also an indicator similarly to the top one, the average seconds. It's just queue size versus the actual seconds.
Yeah, so to get a little bit deeper into that, one of the reasons why we can't tell you this number is too many events to have in Redis is because it depends on the size of the event. They might be a kilobyte, they might be a megabyte. So we don't know how much memory it's actually using unless you could be monitoring your system memory usage, right? But this you see on the bottom side of this Grafana graph, we have the event processing average seconds, or as we call it, the lag time. So this one's pretty easy to conceptualize because you say, if this number is too big, like I'm willing to accept 30 seconds of lag. I'm willing to accept 20 seconds of lag. I'm willing to accept 5 minutes of lag. This is kind of for you to determine, but it's a cut and dry. This is how much time is passing on average between when the event occurred in Ansible and when it got to the database. Now above, we use those other two metrics to kind of have a little bit more of a nuanced insight into the same phenomena, where the blue is based on the growth of that events insert DB counter. We're calculating a rate. And then we're saying, okay, over the last minute, what was my average event insertion rate per minute? And then we're comparing it to the current queue size. Now, what you can think about with this is when the red line, when the current queue size gets above the blue line, that means that based on the past minute, we probably won't be able to process this many events in the next minute. So you can see they're highly correlated. There are two looks into the same kind of situation where the Redis queue size has grown faster than the event processing rate, and therefore we're falling behind.
So we're going to talk about the next one, job scheduling metrics. Scooch in. We're actually going to zoom in on a different part of this chart that we saw earlier. Earlier, we were looking at transform job output and write DB. We're actually going to go ahead and zoom in on this green circle, find capacity to run new jobs. So before we even run a job, we need to be able to schedule that run. And I'm not talking about like going into controller and scheduling the job itself. The task manager is in charge of scheduling jobs, which is a concept we use, or a word we use to describe ad hoc scheduling.
Yeah, so you go in and press the launch button, or you have a scheduled job, and that creates a job in the pending state. The task manager is a periodic task that wakes up and says, oh, I've got 100 jobs in pending. Let me check and make sure that they have all their dependencies fulfilled, meaning like, do they need an inventory update or a project update to run? If not, well, then they're ready to be scheduled on an available execution node, right? So it gathers kind of a map of the world and says, I've got this many control nodes, got this many execution nodes, and I've got this many jobs that want to run. And it decides where and when these jobs can run based on, what instance groups are assigned to them and what instances are actually available, have available capacity. So the two factors that we're looking at as far as is the task manager doing its job well is, well, how much work is it doing in every individual run, and how long is it taking it to do that work. So we've got two sets of metrics here. We've got what I call the workload metrics, which are the task manager running process, like how many running jobs did the task manager have to look at this time? Because it has to look at and determine, how much capacity is currently consumed by the cluster. How many pending jobs did it look at? And how many of those pending jobs did it actually start? So that's the measurement of what's the size of the pie that it attempted to work on. And then the schedule seconds is how long did it take it to do that? So here we've got a dashboard that's looking at exactly these metrics. So the top panel is those workload metrics, and the bottom is how long did it take to process the workload. So you can see there's just yellow lines that we put on here, and that help correlate between when there were more pending jobs and when the task manager took more time, because transitioning a job from pending to starting is one of the more expensive actions that the task manager does. So as you can see, it takes a little bit longer. But on a whole, it's still taking around 3 seconds or less, even on those slow runs. So we're doing pretty good. We actually use these metrics a lot, and we is in our refactor of the task manager for controller 4.3 and AAP 2.3. It's a little confusing with the versions, but in the upcoming release, the task manager has experienced some significant improvements, as far as, especially for dealing with bursts of lots of pending jobs, because we noticed that a lot of our users are automating workflows such that, like, maybe at a certain time of day, they're going to launch a large amount of small jobs via the API because they're bringing in data from some kind of external source that's deciding when it's time to launch jobs. And they're doing this big burst, and we were having issues with the task manager getting bogged down when it was having to suddenly schedule many thousands of jobs at once. So we use these metrics to help us kind of really ascertain were our optimizations successful, and we can, and it definitely was. So I hope that you guys get to experience those improvements in the upcoming release. So I got all these awesome graphs. I got all this information, Rebecca, but the truth is they don't pay me to just stare at a dashboard all day.
They don't?
No. So what do I do? What do I do?
Let's talk about alerting. So up here, we have like a brief little chart. There are a lot of options on how to set up alerting with Prometheus and Grafana. This little chart shows alerts in Grafana, the process for it, and we're going to focus mostly on this. Just like how we're using Prometheus and Grafana to monitor the API v2 metrics endpoint, you can use anything you want for that, and the same thing is true for alerts. We are not suggesting or prescribing anything. Whatever you want to use, you can use. An alert rule is what we're going to focus on today, because I think there's plenty of documentation for other things, but we kind of want to get you started right away. And if we focus on an alert rule, that's how it interrelates with our existing setup. So that's what we think is the most useful. An alert rule is just a Boolean conditional. So we actually can compare multiple metrics at once and then use that to decide Boolean fire or not fire an alert off. So earlier, we talked a little bit about how if Redis is too overloaded and the callback receiver does not have enough capacity to take those events out of Redis, that is bad. And earlier, Elijah's chart actually said the callback receiver was in blue and the Redis queue was in red, and that is the same in this chart right here. And you can see, if you can't tell by my arrow, that this is bad. We think that this is something that we want to alert on. This is something we have an alert on our end. If the Redis thing the Redis queue gets too high, it fails, as mentioned. And we kind of already have a little bit of a tolerance built into this of about 2 minutes, because we think that at about 2 minutes. If it's under that, then the callback receiver can probably burn down that 2 minutes of lag. But if not, we're going to be concerned. So let's go ahead and check this graph and create an alert rule based on it.
So the first thing, in order to get that rate, the insertion rate, we need to take that callback receiver events DB, just like we said, just a gauge to counter that's increasing over time, and we need to create a rate. Thankfully, there's already kind of a built-in function in PromQL, which is the query language that we use here in Grafana. It's called irate. So this here is saying, give me the rate per second from the data from the last minute. Because you see that there's that bracket 1 minute. All of that's kind of subject to your own business logic. You could look at it over the last 10 minutes. You could look at it over 30 seconds. It's kind of up to you as far as over what time you want to calculate the events insertion rate. And then later, we're going to use this data in a like a math expression. And so this irate still outputs essentially an array of data. So it's kind of like a running, what do you call it, insertion rate. But we want to reduce it down to a single scalar value, just a number. So we use, again, another kind of built-in operation. It's called reduce. And we're going to take the mean of that array of insertion rate. So we're going to get down to one number, which is what we're going to call our mean event insertion rate. You see there in the upper left, there's little names in blue. Those are going to be available to us later as variables.
So let's create another variable. We already have the callback receiver average. So let's go ahead and calculate the Redis queue size. We can grab that callback receiver events queue size Redis variable, and we do need to reduce this, but we actually don't care about an average. It wouldn't be helpful for us in this case because we want the most recent Redis queue size. So we're just going to go ahead and use the last function, which is available in PromQL, which is very convenient. And now we compare them.
Yeah, so this is an expression, and this is using the graphical kind of alert builder in Grafana. Later, when we link to the AWX repo, we actually provide these examples as provisioned alerts, meaning that they're like written in a YAML file. That we actually created that YAML by building it graphically and then exporting it. But because the graphical builder is a lot easier to kind of explore and figure out what you want to do, and then later kind of commit that to code after you figured out what you want. So like I said, we've got these variables. So we got $, last Redis queue size, because we're referring back to the variable we defined earlier. We say, so what this expression is saying, when the Redis queue size is greater than the event insertion rate, which the units of mean as event insertion rate are essentially events per second, right? So we want to get everything into events because we're comparing events. So we just say mean in event insertion rate times 120 seconds. So we're saying 2 minutes. This is the quantity of events that we could process in 2 minutes. When that is less than the current queue size, we want the alert to fire. Now, there's additional config that we're not showing here about kind of like back off as far as how long does this need to be true for before you get an alert. So generally what you would see in the UI in Grafana would be if the moment this expression is true, it would say that the alert is pending because it's true, but it's going to wait a certain configured amount of time before it actually fires and maybe reaches out to your contact points.
Ooh, all right, so the chart has come back from earlier. The contact points are on the left or the right-hand side, excuse me, and you can choose whatever you want. AlertManager is or PagerDuty is very popular. So we are using Slack here. This uses Grafana's AlertManager, and this is an actual Slack message to our internal Slack that has let us know, hey, your Redis is growing faster than your insertion rate in your database. It has hit that 2-minute allowance that we've already given it, and it has sent us an alert.
Yeah, so for this one in particular, we've been discussing, there's a couple remediations you might consider. One is, maybe you've got some bad actors. Maybe someone left their job templates on maximum verbosity after doing some debugging, and they're producing an inordinate amount of output, which is putting stress on the callback receiver. Another one is another change we made in controller 4.3 is now in the installer. If we notice you are deploying onto larger nodes, like with 16 CPU or more, we're going to automatically increase a setting that we've discovered a lot of people don't know about until kind of they have problems, which is called job events workers. And it determines how many callback receiver workers you have. And if you have a lot, and the callback receiving process is very CPU intensive. So we say, oh, you've got in 16 callback CPUs. Well, we're going to deploy 16 callback receiver workers so that your callback, your job event processing kind of capacity is increased in proportion to the amount of jobs you're probably running. Because in the past, it was hard coded, or the default was 4. There was always 4 callback receiver workers on every node. And in order to increase it, you had to go in and change this setting on every control or hybrid node. But like I said, generally people didn't find out about it until after they had problems. So we thought it would be a better user experience if we kind of automatically increased it if you had provisioned larger machines. So yeah, there's those. So one option is have more callback receiver workers on your same nodes, produce less output. Or finally, you could provision more control capacity to spread out your job event processing over more nodes. Success!
We did it. We measured metrics.
Yeah, and really they do matter because without it, you're kind of driving blind as far as determining whether or not your cluster is meeting your needs. So with these metrics, we're hoping to give people and ourselves more of an insight and a kind of a cut and dry method of measuring, is controller doing its job well?
We found that a lot of customers weren't actually taking advantage of these metrics in the endpoint. So we really think this will be very useful. Awareness is everything, I guess, in this case. There are more metrics coming, though. So if there are things that you want to be measuring that we're not currently measuring, please open a ticket, file a bug, that kind of thing.
If you're a Red Hat customer, talk to your account people.
Yep, talk to your TAM.
And we really thrive on getting information from customers because there's the sky's the limit as far as things we could do. So it's really great to get some feedback about like what people want because it helps direct our development. And if you're an upstream user, filing tickets or sending messages to the mailing list are really great ways to get involved and just let us know what challenges are you facing, what's information you wish you knew that you wish you because you want to act on it. Because I'm constantly amazed at the awesome things people are doing with our software. They're always probably a step ahead of where I think they might be. So let us know what you're doing and we can hopefully respond. All right. You're not here because this is a recording. So, we'll skip to the resources. This QR code takes you directly to the README in the AWX repo where we talk about how to spin up the Prometheus and Grafana right next to the AWX development environment. We wanted to do this because it's kind of it's a little bit of a, orchestration thing, right? Where you need to have multiple things pointed at each other and knowing each other's passwords, right? So this is a way for you to spin it all up in one and see a dashboard already provisioned, looking at metrics that are already there, and you can peek into, like I said, we're using kind of different the file-based provisioning methods for Grafana. So I'm not going to say you can drop and drag and drop them into your Grafana and it will work right out of the box because there are some variables you might want to set or host names, data source names, all that. But this is definitely a jump start for you.
Please feel free also to rip those files and adjust them to your needs. Like you said, not drag and drop, but like feel free to drag.
Yeah, drag, modify, and drop.
Yeah. The other thing we want to note is this new file-based provisioning. You cannot edit the file-based provisioned alerts.
Yeah.
You can for the other things, but file-based provisioned alerts are relatively new of a feature in Grafana. Hopefully we'll be able to edit those in the future, but
Yeah.
right now you cannot. So when you go ahead and spin these examples up, if you do so, you will see that you cannot edit them. You have to do it via the file.
Yeah, you can't edit them via the UI.
The GUI, yeah.
Yeah, it'll be read only. You can kind of explore the alert a little bit, but you're not going to get to see all of the details. So if you want to like look at the actual queries that we're making in the rule, you might have to look in the files. Also, there's lots of training resources from Red Hat about Ansible, so check these out if you want. Yay! Thank you.
Thanks.
How do we stop?
We do this, I think.
That'd be hilarious.
We don't stop. We just record forever.
Okay, there we go.
There.
Okay.
My God, there's so many steps.